Okay, so today's topic is about transition. Very soon, these things will be owing there. Okay, so this is the one I mentioned already. And of course, this is also I mentioned the sunlight is not available all the time, mainly due to the timing factor. That also sometimes it's true, even though we climb to be 11 o'clock until 3 o'clock, if there is a rain and snow. Of course, in Malaysia, there is no snow, but other countries, European countries, and in Japan, Canada, etc., they have the big issue of snow. So when there is a snow, then the sunlight cannot be, and then dirt and pollution. This is very common in the big cities. For example, like Kuala Lumpur, you have apartments. And then between two apartments, there is no even airflow. And if you place the solar panel there, and there are high chances that the dirt and pollution will cover your solar panel. And it is not easy to go and clean every time. Because when you place it, you are placing outside your house, for example, right? And then it is middle of 20th floor or 18th floor. So you cannot just go out and then wipe it that easily. So sometimes dirt and pollution is also affected. And then the orientation. I think the orientation I mentioned, right? In FKE, they don't just place it horizontally. They don't place it vertically. So they place it with some angle. Normally 30 to 45 degrees is the best angle to receive the sunlight. Okay, so this is just I'm explaining about, this is the first slide I mentioned. What is the difference between conductor and the insulator? Okay, so now only we are going what actually means the difference when I'm talking about semiconductor. So the semiconductors are the materials which normally have one valence electron in the outermost orbital. Okay, now we go a little bit about the theory, periodic table. So don't worry, those who are not really very much familiar on this, I can try to explain to the minimum. Okay, so we all know that the periodic table, normally we say physical periodic table and chemical periodic table. Okay, so here we are focusing on the physical periodic table. If you go to the physical periodic table, then we say group 1 element, group 2 element, group 3, group 4, group 5, group 6. Okay, so this is what we normally call. And what does it mean by group 1, group 2? That means there may be one valence electron in the outermost orbital. Then people who are not very familiar with what is actually orbital, etc., the atomic arrangement of atoms start with a nucleus in the center, and which is surrounded by the three basic particles, which we can say electron, proton, and neutron. Of course, electrons are negatively charged, protons are positively charged, neutrons are neutrally charged. This we know. Okay. And what we are more interested is electrons, because electrons are the particles which transfers the electricity. Okay, so we want to know that how much amount of electrons we have, and it's so specific that the material characteristics are designed in terms of how many valence electron we have in the outermost orbital. So what does it mean by orbital? So the nucleus is at the center. The nucleus is surrounded by the circles, and these circles we call it as a orbitals. And according to the chemical formula, we go SPDF. I'm talking about school physics, school science. So S will have only 2 atoms to the maximum, P will have 4, and then D, F, etc. So when we are talking about the outer ring, so how many electrons are present in the outermost orbital shell is deciding that what type of element it is or what group of element it is. Let's say if the outermost element has only one electron, then those group of elements are called metals. Very simple, because metals are normally conducting in nature. And for example, if it is a semiconducting material, the rule of thumb says that the outermost orbital should have 4 valence electron. Okay, fine. And then, is there any semiconducting material naturally available? Of course, yes, there are 4 semiconducting material naturally available, individual element. For example, silicon, which is well known for everybody. Silicon is one of the semiconducting material. Germanium is another well-known semiconducting material. Carbon is another semiconducting material. Tin, SN, stannum is another semiconducting material by naturally. But out of these 4, why I am saying these 4 are the semiconducting material? If you go to periodic table and look for group 4 elements in the physical periodic table, not the chemical, because in the chemical table they give another number because they go with group 11, group 12, group 20, up to group 20 they go. Choose the physical periodic table. Then this group of elements is talking about the how many electrons it has in the outermost shell. So if you go to group 4 elements, we find 4: silicon, germanium, carbon, and stannum. But naturally, stannum or the tin, the commercial name is tin, is behaving like a metal. So we don't use it as a semiconducting material because it behaves very strong, even though it's 4 valence electron. And when it comes to carbon, carbon is not stable as carbon. Carbon is always in 2 different types. Carbon is in the form of a graphite or carbon is in the form of a diamond. So carbon is normally in 2 ways. So when we are talking about carbon is in the form of a graphite, graphite is nothing but our pencil tip. Okay, so the pencil tip, we normally call it as a graphite. So that's why it may happen sometimes for you also. When you happen to use your pencil to use the 3-pin to 2-pin connection, if you use in the middle your pencil, nothing will happen to you because you are touching the wooden part, okay, which is a non-conducting part or insulator part. But it so happened that if you touch like this, the tip, and then inserting the 3-pin, you will get shock. Because you know why? You are actually touching the conducting material, which is graphite, is a material which we under the carbon. So carbon is conducting material in the form of a graphite. So the moment you touch and then switch on for the 3-pin to 2-pin conversion, then you will get shocked because you are actually touching the pencil tip, which is a graphite one. Okay. Another one is diamond. Of course, diamond is after a long time. That's why whenever people want to know the quality of the diamond, what they say, they call carbon dating. Maybe you heard this term at least, right? Or even if you have a tree, the tree is 4,000 years old or 5,000 years old. How they determine? Then they say carbon dating. So carbon will be divided how much time it takes from one portion to another portion, something like that. So carbon is not stable. Stannum is not available as a semiconducting material. So we left out with only 2 choices. One is silicon, another one is germanium. Of course, germanium is not available that much in the world. So only silicon, because silicon looks very simple. What is silicon? Silicon is available in the form of a sand, SiO2. Silicon dioxide is what? Normal sand, which we get it in the seashore or in any river, etc. But from the silicon dioxide, converting into silicon thing, it's not that easy. The process is very tedious and difficult. So that's why if you happen to see in Malaysia, we have so many semiconductor industries, like Intel, Infineon, Porsche, Texas Instruments. If you go to Kulim High Tech Park, there are so many semiconducting industries. Even in our Batubrana, we can see few. But there is no silicon panel things that produce in Malaysia because the process is very tedious that they do it only in Japan, US and Australia. I think one of the place in German. So only these 4 places, they are coming with silicon ingot and then the silicon material, then they export to all other countries. Okay. So now the rule of thumb for any semiconducting material is 4 electron. So why I say that? So there are only 4 materials, 2 cannot be used, 1 is not available, we have to depend on only 1. But this material become very expensive these days because of the wide usage of this silicon in other resources. For example, maybe a laptop or other semiconducting and electronic devices. So we are looking for a new material. So this is where my research starts. So all this while what I'm talking about is only the theoretical aspect. So So since the semiconducting materials need 4 electrons in the valence orbital, we are looking for a material which have this property other than silicon. Okay, now I go back to the physical periodic table. As I said, if the outermost orbital has only one valence electron, then it is called metal. Then if it is 4 valence electron, we have a semiconductor. So now you can have a mathematics. When I have a group 3 element, group 5 element, okay. So what I'm talking about, there are other group of elements which has 3 valence electron in the outermost orbital. Here I have 5 element in the outermost orbital. So now what I do, I combine these two, 3 plus 5. So 2 elements. So total is 8. They can share by 2. So each will be 4 valence electron. So this is what we call donor and acceptor. So those who are familiar with the electronic or semiconducting theory, very well they know. Those who are not familiar, I can just tell, because the rule of thumb, we need 4 valence electron in the outermost orbital. So whichever element 3 and 5, we just combine together. For example, molybdenum selenide or aluminium has 5 valence electron. Another material got 3 valence electron. I just combine them together. So it's become 3 plus 5 equivalent to 8. Sharing by 2 elements. So 8 by 2, both will get 4 valence electron. Again, mathematically, it looks very easy. But physically, we have to choose a material or medium to do that. What are the other choices? Is it the only one choice, group 3, group 5? No. We can also go group 2, group 6. Because group 2 element has 2 valence electron. Group 6 element has 6 valence electron. So 2 plus 6, 8. Divide by 2. Again, we get 4. So can I go 7 plus 1? Cannot. Why? Because the moment when you say 1 valence electron in the outermost orbital, they known to be metals. Metals are very, very stable. Okay. So only non-metals can able to do this way. Okay. So we can proceed. Okay. So these are the how we can able to do that. And then this is what I said, semiconductors can be, one is the intrinsic semiconductor. We are talking about intrinsic means the particular element. It may be silicon, it may be germanium, etc. I can share all this presentation to the participants. What I explained, maybe you can keep it from the organizers and then you can have more information. But what we call extrinsic semiconductor, by using the doping material. So this is where we can say group 3 atom and then group 5 atom put together. So when we have a group 3 and group 5, what happens? Here there are 3 electron, here there are 5 electron. So 3 plus 5, they become 8 and they can become a semiconducting material. Okay, so these are the theories. So those who want to know the little bit the difference. So conductor, whereby there is no gap. This is what we call energy gap. So the electron transformation can be very easy. And when we go to insulator, the gap is very high between the bands. What is band? The electron need to cross from one point to another point to cross the electricity. If the gap is too high, the electron cannot jump from here to there. So no electricity will take place. So what are the examples of this? So the examples are wood, ceramics, and then plastics, and also we can say glass materials are considered as an insulator. What are the conductors? Anything like nickel, aluminium, iron, copper, gold, silver, all of them are considered as a conductor. Semiconductor is the one we want to play now because we need the 4 valence electron in the outermost shell to take place. Okay. You can ask questions, sir, can we use metals? Because metals already have an electricity issue, right? Why we had to go for semiconducting? Because whenever we don't want to do that, this will automatically stop. When I reduce the temperature, okay, to room temperature, this will become a non-conductor or it will become an insulator. Only when if I want to do the conductivity, then it will be like that. Otherwise, what will happen? When the flow of electron is continuous, then it will be short-circuited. So that's why for the electronic application or the semiconducting application, we prefer to be the materials which are originally insulating in nature But when we want, due to the temperature effect only, it's becoming the conductor. Okay, so now as I mentioned, we are choosing the materials between group 4 to group 6 elements. And then these are all the elements we are using. So molybdenum selenide, molybdenum sulfide, molybdenum telluride, nickel based, tungsten based, etc. And there are information given by this particular scientist from India, Vikram Singh Solanki. He was the batch mate of Abdul Kalam. At least then you come to know they are all working together. And they said the transition metal chalcogenides used in the silicon material are replacing silicon is more economical and available abundant. And then this energy band gaps well suited are replacing the existing one. And also it can give the high absorption coefficient, meaning it can able to receive sunlight in a better manner. So based on this particular work, we are now started working on the material. So I have started in 98 on the tin based material. So I have already completed tin selenide, tin, etc. Then we started molybdenum, tungsten. Currently, I am working on the nickel selenide for my PhD students. Okay, I think these are all some of the results only. Not much actually. I'm just combining that how good these materials are in terms of. Okay, the next one, I want to just focus a little bit on the method. If you see the solar panel has actually a substrate. Substrate is nothing but a base medium, the wall. For example, you want to do the painting. Painting to what? To the wall. So that means the wall must be previously there. You cannot do painting before the wall constructed. Okay. Similarly, whenever we want to do the solar panel is not thick. The material we use in the solar panel is only thin layer of material. But below that, there may be a substrate, which we can call as some kind of supporting material to receive the solar light. Okay. So that means there are two things. There is a substrate, there is a material. So the material is the one we are talking about. So now the silicon material become more expensive. I'm replacing. So to study the property, we are dealing with a technique, thin film technique. So thin film is similar to the coating technique. In the spectacles, we use the sunglasses, then they have a coating, right? The similar one. So similarly, we go the thin film technique to prepare this film because we want to study the characteristics, how good these materials are. So we prepare some of the examples, including the electroplating, the stainless steel spoon. Because if you use the spoon with the metal alone, it will be corrosive, rusting after some time. So what we do, we just dip into the nickel coating or the electroplating, then the spoon become stainless steel spoon. Then this time, if you play with the water or even any hard thing, nothing will happen. So that's why sometimes we had to be very careful if you go to restaurants, because in the restaurants, they use the stainless steel spoon. They claim to be stainless steel spoon. But if they don't use it properly, it may be corrosive internally. Okay, how do I know that? You just go to any supermarket like even Maideen, and if you go to the spoon section, sometimes you will get one stainless steel spoon is 15 ringgit, 1 5, one spoon. Immediately next to that, you will see 4 spoon is only 1 ringgit. Both look same. So then what is the difference? The base material, both of them using only iron, ferrum, no problem. But on top of that, they are coated. So depending upon the coating only, it converting from the corrosive nature to non-corrosive nature. But that's where the thing comes in, how good your coating is. Because they normally use for stainless steel chromium material. The chromium is kind of expensive. So what they do, they just use a minimum amount of chromium. Then they can sell 4 spoons for 1 ringgit. But what will happen? The moment you use the spoon with the hot water or maybe the curry or whatever, it's very hot, there are high chances that the chromium will come out. Once the chromium come out, you are using a metal spoon or the iron spoon, which may be corrosive. Okay, so it's very dangerous. So that's why sometimes people say that we think that they are hygienic in terms of the vegetable or the meat they use, etc. But still, we also need to check. So that's why normally if you go to a restaurant and when you use the metal spoon, the stainless steel spoon, you have to clean with water and see whether this is really clean or really stainless steel spoon. If not, better use the plastic one and then throw it away, because this one is reusable. Sometimes, we don't have a mindset. So we talk about green energy, green energy. Okay, fine. But what kind of things that we are using that may be more dangerous than using the one-time one. So this also we have to be more careful. Okay, so this is the method that we use, which we call electrode deposition technique. And due to the time factor, maybe I can bit go faster. So we have successfully prepared the new material, and then we have the results also. Okay, so these are all the results that we obtained, how the structure used to be. Okay, and this is the most important property to decide whether a material can be a semiconducting material or not. Then we have to check the band gap, so the energy gap. So surprisingly, we can see that our materials are falling between 1 to 4 electron volt. What does it mean by? This is the semiconducting material range. So the energy gap, just to tell what is meant by energy gap, maybe I can just show in one picture. Okay, this picture we can see here. So here in the case of conductor, there is no energy gap. In the case of insulator, the energy gap is very high. So in the case of semiconductor, we prefer between 1 to 4 electron volt. So this is what preferable semiconducting material. So our materials have these results. Okay. So between sorry, this is thickness measurement. Okay. So the energy gap is between 1 to 4 electron volt. So then we can see that this material can be replacing. But this is still a long way to go because we are only at the experimental stage. Then we have to prepare this material in the form of a silicon solar panel, and we try to replace the existing one and then see the performance. Then only we can able to do. And these are all some of the results to be weather suitable. You can see energy gap of one particular material is 1.17 electron volt. The another one is 1.68. The third one is 1.92. So all of them are giving a promising result for us. So what I can simply conclude here, okay. So in a nutshell, the first one, what is the issue here? The natural energy resources are very limited. Okay, fine. So we need to have a renewable energy. Renewable energy are many, but we choose solar energy. Fine. But even when we are choosing the solar energy, the currently existing material is silicon. But silicon become very expensive these days. The usage of silicon become more and more in the semiconducting and electronic industry. So we are trying to replace the silicon material with other material, and we have chosen this particular topic, transition metal chalcogenides, meaning to say in the periodic table, group 2, group 6 elements or group 3, group 5 elements, because theoretically this is also a semiconducting material and we are doing the experimental work. So we have some successful result, but still a little bit more to go before we can actually use it commercially, whether this can be a true solar panel materials or not. Okay, and in this occasion, I am acknowledging my students and then my colleagues and collaborators who are either directly or indirectly assisting to this presentation. And also I thank to the all the research groups and things that I'm involving. And this is with that I end my presentation today. So I'm happy to share if you have any questions or so. I'm sorry, maybe I take extra 5 minutes time. Sorry about it. Okay, I also give those who are, I know sometimes there may be a student participants, though may be interested. So I'm giving the definition of all those things, considering as a lecture. So what is actually solar, photovoltaic cell? So all the definitions also I'm including at the end. I have already shared the presentation slides to the team. I hope they will share to you later. Thank you very much.